Okay, hello. Welcome all to Math 219, Summer 2023, Term 1. I look forward to working with you in this course. I am Clark Bray. I'm the instructor for the course. And historically, I have spent a significant fraction of the first class meeting talking about course logistics and advice for how to do well in the course and things like that. It ends up taking surprisingly a lot of time when we, in fact, really don't have the time to spend. Math 219 is an extremely full course with lots of material being covered. And we just can't afford the time. So what I've been doing in recent years is recording my introductory discussions about the course organization and that sort of thing. So here we are. All right, I'm going to try to keep this as tight as possible. But again, there are various things that I really have to say. So it is what it is. Okay, first, very quickly, if you are thinking about a math major, possibly, perhaps, hopefully, then please come talk to me. Nothing particularly urgent or critical, but it would be a good idea to just, check in and make sure that you've taken the right courses, that you're, certain questions that should be asked and things that should be checked. Okay. Now that said, let's get into the course organization. So I have a class website. This is a brand new class website as of this summer term. I am switching out of Sakai, which has served effectively as a course website for me for the last several years. I'm switching now into just streamlined, bare bones, but efficiently organized, I hope, website for doing that instead. So anyway, here is the location. Right here, and I imagine that I will, in the near future, probably in the email that you received that directed you to this recording, I should have that link in there as well, so you shouldn't have to type this in. But anyway, just in case, there it is. Okay, this comment down here doesn't apply to us. I'm the only instructor of the course this term. Okay, so the most important thing is to make sure that you read through all of the very important information that is on that website and familiarize yourself with links just to make sure you know what's where. But all of the discussions, make sure to read and understand. So I do want to talk you through some of the particulars on this website. I'm going to start with the content syllabus. Now, here we go. This is the website. And the content syllabus, you'll notice right here is the very first link. And let's see here. Why don't I make this text bigger? There we go. That's going to make it easier to see. So content syllabus right there. You click on that. And here we go. This is the what we call the content syllabus. So this has all of the content for the course is all listed here. Anything related to content for the course. So, for example, here's a listing of the textbook, Vector Calculus by Colley. This is an excellent book. I like it very much. Let's see here. So, there's a discussion of prerequisites here. You're responsible for all of the prerequisite material listed below. That's this section down here called prerequisite material. There's various things in here. Largely, it's the prerequisite trail of courses. So this course requires linear algebra. Linear algebra really effectively does require single variable calculus. Single variable calculus requires high school, geometry, algebra, trigonometry, etc. Okay, I do note also some specific aspects of linear algebra that we're going to make a lot of use of. So please do make sure that you are comfortable with all of that stuff. I will say a few things about it in the first day or so of class, but still it's a good idea to make sure that you're on your own, that you're good with all that stuff. Okay. So some specific things to make sure that you're aware of. Note down here in the once we get into the listings, there are section numbers and then section titles. These are all straight out of the textbook. There are exercises listed. So when we get around to having covered, for example, this section on the cross product, once we are done with that section, then these exercises in the textbook are the ones that will be part of that homework assignment. And I'll say some more words about that in a minute. Okay. So, now notice also, there is a column over here called excluded material. So some of the material in the book is not part of the course. And for this textbook is arguably maybe just a skosh high of a cut for Math 219, but I think better too high than too low. So I think this is a very well suited book for this course. Anyway, so because there are some topics that are a little bit more mathematical, proofy, that kind of thing than we want in Math 219, there are certain topics that you are not responsible for. That they're in the book, right? They're in section 1.4 on the cross product, but you're not responsible for it. And those topics that you are not responsible for will be listed in this column, excluded material. In this case, there is an addendum in that section that gives proofs of certain properties of cross products. And that's not part of the course. So anyway, keep an eye as you are reading the textbook and in preparation for lectures, that kind of thing. Make sure to keep an eye on this column of excluded material, and that'll come in handy. Notice also there is a column called included material. There are some topics that I, to my frustration, are just not discussed in the book at all, but that I think really are important in the subject of multivariable calculus. So there's only a few of these. But when we get to section 2.5 on the chain rule, well, there is a second derivative discussion to be had there, and the book doesn't give any discussion of that. Again, I think that's unfortunate. So anyway, we will be including that in the course. We will be covering it in, you'll see here, the lectures, and it is in the lecture notes, which you will see when we get there. Anyway, this column of included material is additional stuff that will be covered in the lectures that you are responsible for, even though it's not in the book. Okay. All right. So you'll notice there are a bunch of sections and topics listed, and I think this page has everything that you will need to know about what is covered in the course. Okay. All right. Let's see here. Back to my outline here. The course schedule, I believe, is the next thing on the page. Yeah, look at that. There it is. Okay, course schedule. So I'm going to click on that. And this is how we'll keep track of what the plan is for any given day, and homework assignment dates and homework due dates and exam dates and holiday dates. And there's just a lot to keep track of time-wise, and it's all on this course schedule. So roughly speaking, I think it's pretty self-explanatory. So you'll notice for our first day of class, let's see here, I hope I have this right, Wednesday, May 17th. And so that's, let's see, 1 week from today. How about that? So on that date, the goal is that in the lecture notes, we will get to chapter 1, page 5. That's my goal. That's my target. That's what I'm hoping that we'll be able to accomplish on the first day. We'll see what actually happens. What actually happens, I will document largely just for my own purposes, I suppose. What we actually finish, I will document here, and I'll indicate chapter 1 and page whatever we actually get through on that day. Okay, and this can be useful for y'all as well. Knowing where we left off with the last lecture can be helpful to you if you want to, as I think everyone should, do a little bit of previewing before the next class meeting to kind of read ahead in the lecture notes, read ahead correspondingly in the book to do some preliminary planning for the next lecture. Okay, right, that's that. Now, while we're on this column, let me point out that holidays are noted here. So Memorial Day is a holiday, no class meeting. Juneteenth is a holiday, no class meeting then either. Notice that we also have exams noted here. The date of the first exam, you can see here, is Tuesday, May 30th. And the date of the second exam, Monday, June 12, et cetera, et cetera. Well, et cetera, in the sense that there's a third exam and that's it. So anyway, so those are the exams. All right, on to the next column, next set of columns. Homework assignments. So, on our first class meeting, on this first date, we may or may not actually finish book sections. If we do, I will denote them in the corresponding cell over here, this column called sections assigned, and that's how you know which lines from the content syllabus are going to be part of that homework assignment. Okay, so I can't fill this in yet because, of course, I don't know what we're going to finish on any given day. But it'll be filled in as we go through the course. Typically, I should have that filled in almost immediately after class, or more likely after office hours that day, which I expect will be right after class. Okay, when is the homework due? Okay, well, again, if we finish enough material in order for me to assign homework on this first date, the homework will be due on Friday, May 19th. Okay, so you'll notice for every class meeting and thus every potential homework assignment, right, on any given class meeting day, we may, hopefully, presumably on most, we will finish an actual homework assignment, or at least, or an actual book section, something I can assign for homeworks. What is assigned will be listed here, and when it is due will be listed there. Okay. Now, let's talk about the schedule for this. You may notice that these turnaround times are pretty tight. So, for example, what we finish on Tuesday, May 23rd, you see, is due on Thursday, May 25. Why is it due that fast? Well, it's due that fast because everything in this course, being as it is a summer offering, and that's really the point. It's the fact that it's a summer offering. Summer offerings go really, really fast. And a week, it's like 2.5 weeks. In a semester. It's a long time. And if I were to have material, an entire week's worth of material, for example, due at the end of the following week or something, well, students would regularly be just way behind on the material. And I just don't think that this is a good plan. I think students should be working on homework as immediately as possible in order to keep up with the progressing course material as much as possible. And having these tight turnaround homework due dates does that. Okay, so let me walk you through the strategy. The idea is this. So again, let's suppose we're talking about work that's done in class on this Tuesday. The idea is that on that Tuesday, students will start working on the assigned exercises that afternoon. Students should be starting the exercises as soon as possible, and that afternoon is very reasonable. Now, I don't expect you to finish that afternoon. Some of the exercises, hopefully and presumably, you can finish right away. But some of the exercises, you might discover, by the time you get to some of the later exercises, maybe Tuesday evening, you might find that you're stuck on some of them. And this is normal. This is okay. It's not a problem. The idea is, though, that the ones on which you're stuck, the next day, Wednesday, you have the whole day to seek help. Now, where would you get that help from? Well, there's going to be TA office hours, yet to be determined. We haven't worked that out yet. I have to discuss that with them. And there will be my office hours. Those are two good resources. And there may be additional resources We're not exactly sure just yet what the Academic Resource Center might be able to offer. Of course, then there's also the possibility you can get help from a study group or something like that. I'll talk about study groups in a little while. I'm a big fan. But one way or another, from any of these resources, you'll get help on the questions that you got stuck on Tuesday night. You'll then have the rest of that day to finish up those exercises. And then, just to give you that additional little bit of flexibility, they're due on the next day, being Thursday. So the idea is I understand that, sometimes, things, get out of a regular schedule and you might not be able to, finish writing up the solution or something. And so you do have until, the next day, which you might call the third day, to actually get it submitted. Do notice that all of the due dates are 11 p.m. Durham time. This again is to give you sort of maximum flexibility for that date. And so I think this is a perfectly reasonable schedule, and yet I think it also will keep students, if you stay on schedule with the homeworks, then you should be staying up to speed, up to date with the progress of the material to a reasonable extent. Okay, all right. So that's the plan. Okay, let me interject with any of this organizational stuff. If you have any questions, you are very welcome to come and talk to me about it. Totally fine. Just come to my office hours and we'll talk about it. Okay, very good. Alrighty, let's see here. Back to my my organizational notes here. Course grades. That's a good topic to talk about. How do course grades work? Well, notice that I have a link here called Course Grades. Again, just to be clear, we're on the website, the class website that I will have emailed to you. So again, course grades. So roughly speaking, all graded items are going to be converted to the 4-point scale one way or another. For the midterm exams, this is going to be by way of a curve that I will set specifically for every individual exam. For other things, like for the homework, there is a different system, and it's all discussed here. Make sure to read that. Attendance counts for part of your grade, and that system, how that works and how you'll get that onto the 4-point scale is discussed here. Make sure to read all of that. The punchline, though, is that we will eventually be computing for all of these graded items. We will be computing something called your weighted average for the course. So all of the graded items will be on the 4-point scale, and weighted average just means average, really, where you count some items in some sense more heavily than others. You can Google the formula for a weighted average. It's very easy Google, but it's pretty straightforward arithmetic. These are the graded items that will contribute to your course grade. It's the midterms, all 3 midterms, the homework, and class attendance. And they count with weights as indicated there. And once that weighted average is computed, your weighted average will fall into one of these several bins. And so, for example, let's suppose that you end up with an average of 3.68. Well, that falls into this bin. 3.68 is in this bin, in which case you get an A- in the course, hypothetically, of course. So it's a pretty simple system. It's just weighted averages. Everything's on the 4-point scale. Everything is converted to the 4-point scale. And then, these bins, by the way, are pretty simple, pretty simply defined. These are the numbers that, are closer to 2.3 than any other grade. So that's most of how these bins work. You will notice that near the top there is some funny business. Some of those bins are a little bit different. The cutoff for a flat A is a little bit lower. Good news, a little bit lower than you would expect. You'd expect a 3.85. But this is for statistical reasons, and what happens when you average numbers tends to pinch in distributions a little bit, and so this accounts for that in, I think, a reasonable way. Okay, so that's how grades work for the course. There's a few other things to say here that I'm going to let y'all read. Some students may be entertaining taking this course on an SU basis. There's some words of warning about that. There's some other comments here about course grades. I'm going to let y'all read all of this stuff. Okay, so there we go. We're making progress here. Okay, YouTube recordings. Now, this is something that I can't talk about as I make this recording, at least not very well. But you will see our playlist for this course by the time you receive this recording. So you'll notice there's a link right here, again, on the class webpage in the second column, YouTube recordings. You just click right there. This will bring you to my YouTube page. And then let's see here. You click on playlists. Every playlist, well, pretty much, represents a course, one of my course offerings. And I'm going to click on this recent Springs list, just as an example. And here we go. And so here's the complete list, and you'll notice here that there are all the recordings that I made that semester. And I had three sections that semester, so there's actually a really large number of recordings here. There'll just be one per class meeting in this summer term. Okay, so click on one, and it starts playing, and it's like being back in the class meeting. Okay, so I hope that will be useful for you. I think this is a really valuable resource. It's an opportunity to hear it all over again, and you might don't even have to listen to the whole thing over again. It's you can make notes in your class notes of particular things that you want to listen to over again, and then you just, of course, click over to the appropriate moment and listen to whatever you need to listen to. Okay. All right. So, again, I'm a big fan. I hope y'all will make heavy use of these recordings. Such a thing did not exist, of course, when I was in college. But I always kind of wished in some abstract sense that I couldn't even really imagine. Wouldn't it be nice? Oh man, that'd be so great if I could, golly, what was it that I know this sounded important when he said such and such, and I don't remember what he said. Well, wouldn't it be useful to be able to hear that again? And y'all have that capability now. So, again, I think it's a really useful tool, and I hope you'll capitalize. Okay, all right, moving along. So I want to talk about the learning goals for the course. By the way, that is another thing that's discussed on the web page. There is a whole sub-page here called Learning Expectations, and I hope you'll read all of this very carefully. These are all really important points, and make sure to read all of that thoroughly, so you know what you're supposed to be doing, what you're supposed to be getting out of this course. So I don't want to effectively, reproduce the entire web page in this recording, but one of the big highlights, arguably the big highlight, is that this is a course about ideas. That's what we're here for. A lot of students misunderstand and think that the answer at the bottom of the page is what's most important. This is not true. This is a misunderstanding of what math is. Math is not get the answer by whatever means, by hook or by crook that you might want to. No, it's about understanding ideas and being able to apply those ideas in context. So that's the focus. Now, of course, if you do understand all the ideas, one thing that follows from that is you will be able to get answers, and that is true. And that does present an opportunity for testing students is, hey, let's see if they can get the answer, because if they did, then seemingly that would suggest they understand the ideas. What remains, though, unavoidably, is that it is still the ideas that we are actually interested in. And it turns out that if you entirely trust students' abilities to get answers to be the only evidence you look at to see if they actually understand ideas. Well, it turns out there are actually a lot of problems with this. Students can get answers by following algorithms, memorized algorithms that they don't actually understand, so this is not a good thing. Anyway, very important point. Focus on the ideas. That is what the course is about. That's what the exams are going to most heavily focus on. That is what grading of the exams is going to focus on. And whether you have the correct answer at the bottom of the page marginally contributes to grading. But it's really, really not the point. Okay, all right. So related, I'm just saying kind of the same thing over again. It's about reasoning. Reasoning is, I guess, arguably an idea. Reasoning is something you do with ideas, depending on which ideas we're talking about here. But reasoning is something that we want to see on every exercise, every exam question. Everything that you do and produce for this course, we want to see your reasoning. That is, again, fundamentally what mathematical communication is communication of reasoning. So, again, it's not just whether you get to the right conclusion. It's a question of whether your reasoning is valid, whether your reasoning is complete, and not whether your conclusion, as this happens to be the right conclusion. Okay, so enough about that. Let's see here. You're going to notice this very heavily reflected in how I do the lectures in this course. There's going to be a lot of talk about ideas. And there will also be some talk about algorithms and processes. Techniques, sure. But that's only part of it. And again, understanding the ideas is really the purpose of why we're here, what this course is for. So again, it's when I'm talking about ideas and reasoning, development of mathematical tools, etc. This is not just me entertaining myself. This is me giving you the good stuff. That's the what you're most likely to have the most trouble with getting out of the book is understanding the ideas. The algorithms and the processes are usually pretty mechanical and not usually the hard part. Okay. So yeah, again, when it comes time to grading, when it comes time to assessing your work on exams, we're going to be looking at your reasoning. That is the validity of your reasoning, the completeness of your reasoning. We're going to be looking for clarity of thought. Did you get right to the right approach, or by contrast, in some cases, some students will meander around pointlessly, inefficiently, before getting to the right conclusion. This matters, right? This shows less understanding, less proficiency with the ideas, which again is what this course is about. And then also clarity of written communication. So your ability to communicate your ideas. This is actually also really important. For one thing, because we can't understand your understanding of ideas if you don't tell us, right? So being able to communicate your understanding clearly will help us understand what you understand. But then furthermore, just keep in mind that, how math is done, how math is applied, be it in, an industrial application or graduate program or just, future math classes, future, physics or engineering classes or what have you, that'll be using multivariable calculus. The way that multivariable calculus will be used is, you'll be, communicating about it in writing. And the ability to do that is itself intrinsically valuable. Okay, so that's a lot of words, a lot said about this point here. A strong case can be made that this paragraph here is the most important part of what we're talking about here in this recording. So please do make sure to understand all that, digest that, and make sure that you keep this in mind in all that you do in this course. Okay. Alrighty, so on to the next thing. So how are you going to learn the material in this course? So I want to point you first to a sort of the half of the course web page called How to Do Well in This Course. Here we are on the course web page again, and notice this entire column, are, from a certain point of view, half of the web page is not about just logistics, right? But is about advice. What should you be doing? How does one achieve all of this that I've been talking about? And there's just a tremendous amount to say about this. So there's a very important page here called Course Design and Strategy. I want to draw your attention to this specifically. There are different schools of thought on how to teach a course and what's the most effective strategy for teaching a course. And I do it as follows. I want to optimize the learning experience specifically on the assumption that students are optimizing their learning experience as well. So in particular, I am designing the course for students who are doing everything that they should be. In other words, making full use of all of the available resources for the course. So, in other words, it is not my goal to teach class in such a way that the amount students understand at the end of the lecture is as much as possible greater than the amount that they understood before the start of the lecture, because it's just not where the learning happens. I think it's very, very important to recognize that a very huge amount of the learning happens outside of class. Right? And this is important. I think that this is if we're going to get through this as well as possible, I can't do it entirely on my own. I need students to be doing a tremendous amount of stuff as well. So the idea is that students will preview the material before class, as I already mentioned. Then, of course, you come to class, focus, think, right? Do your best to follow the class. And then, furthermore, continue reviewing the material after class is over. Now, each of these, I think, is a critical step. This is a kind of a vertical structure. Each one of these steps is a foundation for the next one. And so you remove any one and the whole thing falls down, right? So I think all of this is important. And I'm going to be assuming all of that as I design my lectures. So again, not trying to design it in such a way that students, I'm not trying to optimize the in-class exclusively, the in-class learning. I'm trying to optimize the overall learning. Okay. All right. So that's an important point to realize. There's a lot more in this column. There's a list of course resources, various things that you should make sure to be aware of that can help you with your learning. While we're on this page, I will point you in particular to all of my past exams. So I'm going to click here on Math 219 exams, and I've only been teaching 219 for a couple of years now, if that. Let's see here, year and a half or so. It's a pretty new course, and that's why I've only been teaching it for a short time. But you can also look at my old Math 212 exams, and this course I've been teaching since 2004. Not quite continually, but almost. It's been the course that I taught the most over the past nearly 20 years now. So this is a tremendous number of old exams, and each of the exams comes with solutions. So these were the solutions that I wrote for, let's see here, 2017 fall, looks like. And so you can see what the question was on the exam, and then here is my solution. Okay. There's also blanks, and I think this is a good thing as well. Notice with these blanks, there's just the question. And this is a good thing for you all to have in case you want to, maybe use it as a practice test. Self-administer the exam and, pretend that it counts for a grade and, time yourself for 50 minutes or whatever whatever the time was. 50 minutes. And then you can effectively grade yourself with the solution. So anyway, these are a lot of good resources. I hope you'll capitalize. Note further, there's a whole nother folder here called summer midterm exams. My summer exams have, at least for many years, were different. And they were different because I taught out of a different textbook. I taught out of my own textbook in the summers. And that's when I was teaching Math 212. I'm not doing that anymore now that I'm teaching Math 219. But these exams are very, very, very similar to the other Math 212 exams, which are, of course, also very, very similar to our Math 219 exams. These are all multivariable calculus exams. The differences between these courses are slight, and so all of these old exams are great practice material. Okay. All right. So again, I don't want to read through the entire web page here, the entire website. So I'm going to let y'all read the rest of that. Let's see. I think we've already clicked on learning expectations. So anyway, make sure to read all of this. There's a lot of really, really important ideas here. All the rest of this stuff. Schedule advice. This is actually an interesting one to look at. This is an example of a reasonable daily schedule for this course. And part of what I like about this list is how extensive it is. The idea is you should be doing all of these things every day. And I know it looks like a lot, right? It really does. But this is, there's just a lot of things that you should, be keeping up with and, strategically. Everyone's going to have different personal circumstances, other commitments. So this, it's not going to be exactly the same for everyone. But I think everyone should look at this example and plan to try to do as much of this as possible that the rest of your schedule permits. All of these items are helpful. Okay. All right. Let's see here. And then while we're here, let me just real quick comment on this general advice page. This stuff is, it's things that I think will be helpful. It's, so for example, you don't have to work in groups on homeworks. So this isn't a policy. Exactly, right? But this is a suggestion that I think will be helpful in the long run. And et cetera, et cetera. There's a bunch of stuff in here. I think it's good advice to, do everything that you can. If I can get this thing to highlight, there we go. To, write neatly. You'd be surprised. This can make a big difference. I see it happen all too often that students misread their own handwriting and as a result make algebra mistakes. And far more common than that is graders being unable to read student handwriting. And this is not appropriate. Anyway, this is hopefully for most of you this is not an issue. But I just want it on record that we really strongly encourage students to present themselves well. With seemingly trivial things like legible handwriting. Okay. All right. So again, there's way too much for me to talk about in this recording, but I want y'all to make sure to read all of that stuff, and I hope it'll be helpful. Okay, back to this page. We've actually already covered now most of these things down here. I do want to highlight this trio here. Notice this is what you should do before class, and then make sure to come to the class meeting, to the lectures, and then study again after class. I think this is a really important sort of 3-step process. You'll get more out of the lectures if you preview the notes in the book in advance and kind of know in some sense what is going to happen in class, at least with the broad strokes. And then having gone to class and, understood as much as you can, I think it's just invaluable to reread everything and try, read for with a fine-tooth comb, trying to understand all the details that maybe you didn't quite get in class. But after class is over is the time to really try to solidify everything. Okay, I'm also going to focus on this idea here, annotating your copy of my lecture notes. I'm a big fan, by the way, of students coming to class with a copy of my lecture notes, such as, here we go, this is some of my lecture notes for Chapter 1. And this is what's going to be up on the screen. This is going to be what I'm going to be, I will be annotating myself. I'll be, pointing to certain things here. Okay, we've got this A vector there, and we've got this B vector here, etc. So this is where the lectures will come from, and if you have a copy of this of your own, then you can annotate for yourself, and you can say, this thing here, that's what the plus means. And I might not actually do this live in class, right? This line in purple here. But if you want a clarification for yourself, boom, you just do that. You don't have to recopy the whole thing. You don't have to transcribe what you see on the screen. You can just annotate with just the specific bits that you want. Okay. Let me also call your attention to time stamping. Let's see, where did I write this? Yeah, there we go. Timestamps. I think this is a great idea. So, for example, here's a point that very often students get confused about. I define here a certain function. Whoops, I clicked the wrong button. A certain function here called capital D. And I make the assertion that this is a linear function. And students very often get confused about this because they see that D is defined with a determinant, and they don't remember the word linear being used in connection with the determinant function. This is a little bit of a confusing point. There are some subtleties about the statement that's being made here. Now, I'm going to elaborate on all of this in class. Again, I'm not going to reproduce an entire lecture right here. But there are some things that I'll say about this in class. But you still might not entirely understand this point after this part of the lecture. The idea then is that you can put a timestamp right here, and I'm going to notice down here on my laptop clock it says this is at 3:17:42. Okay, so I'm just going to put 3:17. That's close enough. And now, at some future time, after the lecture is over, when you're reviewing the notes, you'll see this right here. And this is your note to yourself, your reminder to yourself that all you have to do is go to the YouTube channel, go to this playlist, and click forward to the point where the little clock down here says 3:17, and you can listen specifically to this point discussed again. And having done a little bit of background work, having maybe, perhaps you spend a little bit of time with the idea of linearity. Maybe you sort of review the idea of linearity, which I think is discussed. Here we go. Linearity is defined and discussed in, compare and contrast here. And maybe with a little bit of that reminder, the recording, listening again to my explanation of this point might make more sense. Okay, so I'm a big fan. I hope you'll use this. Making these timestamps, I think, will be a really, really efficient streamlining of your study process, and I hope you'll take advantage. Okay. All right. So again, I think a lot of the rest of this we've already talked about. Oh, here's one that we didn't. Maintaining a list of questions. This was very, very valuable to me when I was in college and in graduate school. It is to be expected that you won't understand everything the first time you hear it. Of course. My gosh. Wouldn't it be great if we just understood everything the very first time we heard it? That would be amazing. But that's not realistic. So when you experience something that you don't understand, you should have a list. And jot it down on your list. And then this gives you reminders of things to pursue when you come to my office hours, or when you go to one of the TA office hours, or when you meet with your study group, whatever. Go through and ask those questions, and then just cross it out once you got it, once you feel comfortable with it. You cross it out. You don't need to pursue that question anymore. And then anything that's not crossed out, you need to continue to follow up on. I think this is a really nice idea. Okay, so again, on the web page, there's a page called Course Resources. Make sure to look at all of that. I've already said this a few times, but let me just repeat. I am a big fan of the idea of study groups. In particular, don't think of a study group as a way to divide labor. That's not what it is. It's not what it's intended to be. I think the best way to use a study group is to create a dialogue. Get a conversation going. Get a back and forth in some way or another, either between yourself and someone else, or between two other people that maybe understand the material a little better than you do, and you want to hear them trade ideas so you can kind of piggyback off all of that. Dialogue, I think, is just fantastic as an opportunity for learning things that you don't understand. If you're talking with someone else who understands what you want to understand, they explain it to you. Fantastic. If they ask you to explain something to them, then, of course, you get to help somebody. That's always nice. But furthermore, this is an opportunity for you. As you are explaining something to them, you are reinforcing your own understanding. In fact, if it's something you've only just recently understood, you will find it challenging to explain that idea to this other person. And that process of taking an abstract understanding that you have in your head and turning that into understandable language is a brain-intensive process. And it helps sort out ideas. It helps organize ideas in your mind. And you will understand it better after having communicated it to someone else. Okay. All right. Okay. And then I guess while we're here, I'll go ahead and hit this last point. Don't think of the homework as something to get through. Think of the homework as an opportunity. This is a learning experience, and it's practice. Specifically, it's an opportunity to practice how you would write answers on exams. So on an exam, of course, it is required that you show your work and explain your reasoning. That's where points come from on the exams. So do the same thing on your homework exercises, right? It's, like I say, a great opportunity to practice that which you will be graded on the exams. So very useful. Okay, all right. So that makes it through the list. I hope this was a useful. And I just remember. Okay, one other thing. I'm sorry. One other thing I do want to hit is the one link here that I haven't been able to actually link yet. So there is this thing called exam curves. When we get to exams, once the exams are graded, again, as I said earlier, for every exam there will be a curve. This is where you will click to get those exam curves. And I have an example exam curve page. This is from a couple semesters ago, or the fall, so the semester before last semester. And this is roughly what our exam curves page will look like as well. So notice that there's a separate curve for each of the 3 exams. The curves are different because the tests were different. Some were harder, some were easier. So you'll notice that you get different letter grades on the 4-point scale for different scores depending on which exam it is. So for example, just as an example, 79 on the first exam. On the first exam, that translated to a 3.25, which is kind of a B+. It's almost exactly a perfect B+, a little bit lower than a standard. Standard B+, of course, is 3.3. But the second exam was a little bit harder, and so 3.25. In order to get a 3.25, you needed 79 points on the first exam. You only needed 70 points on the second exam to get that same, pretty much same grade of about 3.2. Anyway, pretty close. Whereas that same score of 79 on the more difficult second exam merited a higher grade. It merited a 3.55, which is slightly closer to A- than it is to B+. So this is what we'd call a low A-. Okay, anyway, so there will be curves for every individual exam. They will be completely different numbers than what we're looking at here. Every exam is different, semester to semester, term to term, right? They're always a little different. And how you will convert your raw scores to the numbers on the 4-point scale that will contribute to your weighted average will be right here on these curves, which you will find right here, the exam curves link on the class website. Okay. All right. And I really think we're done now. Okay, I look forward to working with y'all in this course. See you next week. I hope everybody has a nice little short period of relaxation between now and then to recover from spring semester activity. Look forward to working with you for the first half of the summer. Okay, see you then. Bye-bye.